Deep inside the ruins of the Chernobyl nuclear power plant, there's an object so dangerous it can kill you with just a few minutes of exposure. It's not a weapon, it's a mistake. A monster made of melted nuclear fuel. It's known as the elephant's foot. And its story is a seriously chilling lesson about what happens when our most powerful creations spiral out of control. So this isn't just a history lesson about a nuclear accident. It's really an attempt to answer that fundamental question. Because the elephant's foot, it's the solid, physical answer to what happens when our technology escapes every boundary we build for it. Every design, every bit of oversight, every layer of control. To really wrap our heads around this thing, we need to know what it's made of. It's a mass of something called corium. And you can basically think of corium as nuclear chaos. It's a lava made from the melted down heart of a reactor. And the elephant's foot is without a doubt the most extreme and terrifying example of it on the entire planet. Okay, so how on earth did an object like this even come to exist? Well, its creation story is just a terrifying sequence of events that pushed physics and materials way beyond their absolute limits. It all started with a runaway reaction. The core heated up to over 2,000 degrees Celsius, hot enough to liquefy everything. And we're not just talking about melting here. This was a complete fusion of everything inside. The nuclear fuel, control rods, steel, sand, even the concrete floor beneath it all. This superheated lava then just burned its way down. It wasn't a slow leak, it was a violent, destructive river of molten nuclear material that carved its own path right through the power plant, until it finally came to a stop in a service corridor deep below, where it slowly cooled into the shape we recognize today. Right after it formed, the elephant's foot was kicking out an estimated 10,000 Röntgen per hour. It's a level of radiation that's almost impossible to comprehend. And let's be crystal clear, this was not some theoretical risk. It was a straight-up death sentence. Standing anywhere near it for just a couple of minutes meant you're gonna die from acute radiation syndrome. Your cells would start breaking down in seconds. But, this thing didn't exist in a vacuum. Its very creation forced an immediate human reckoning, one that was measured in sheer sacrifice and mere seconds of exposure. This quote right here from the source material, man, it's just chilling. It shows that when they were faced with this completely unprecedented danger, all the normal rules of safety just went out the window. The response became a desperate, awful calculation of how much of a person's life could be gambled for just a few seconds of work. For the first responders, the people they called the liquidators, this was their new reality. Their work shifts weren't measured in minutes, they were timed with a stopwatch in seconds. They were using makeshift lead aprons because advanced robots just failed, their electronics fried by the intense radiation. And tragically, several of the first engineers who managed to locate and photograph this mass paid for it with their lives. The impact of the elephant's foot radiated far beyond Chernobyl. Its existence sent a massive shockwave through the entire global nuclear community, forcing a complete overhaul of what worst-case scenario actually meant. Now take a look at this comparison. It's fascinating. When the Fukushima disaster happened in 2011, it also created corium, but it looked nothing like the elephant's foot. So why the huge difference? Well, it comes down to reactor design. Chernobyl's graphite moderator and the catastrophic failure of its containment building allowed this single, massive, exposed object to form. In Fukushima, the containment held up better, and they were able to use seawater for cooling, which prevented that kind of single, monstrous formation. The design choices made decades earlier had a profound impact on the outcome. The elephant's foot became this catalyst for massive change. It brutally exposed the fatal flaws in Soviet-era secrecy. It directly led to new international rules that demanded transparency and peer review. Regulators were forced to finally accept that accidents beyond their design basis could actually happen. And that led to brand new safety tech, like core catchers, which are designed specifically to stop a corium mass from melting its way through the floor. So in the end, the object went from being just a piece of a disaster to an essential piece of data. It was the physical, undeniable proof that the unthinkable was in fact possible. It anchored all those abstract risk calculations to a very real, very deadly thing. So fast forward a few decades, and the elephant's foot is still there. But its legacy has shifted. It's now a permanent problem, a challenge not of cleanup, but of indefinite containment. As this chart shows, the immediate danger has faded, a lot, thanks to simple radioactive decay. From that insane 10,000 Rentschend per hour back in '86, it dropped to just tens of R per hour by the late '90s, and it's even lower today. But, and this is a really big but, less lethal is not the same thing as safe, not by a long shot. It's still hazardous enough to kill you if you hang around for a few hours. And containing it is a generational problem. That first sarcophagus they built in a hurry was always meant to be a temporary fix. Then in 2016, the massive new safe confinement structure was slid over the top, basically an engineered tomb designed to last for 100 years. But the thing inside? It's going to stay dangerously radioactive for thousands of years after that. Which brings us to the core, unresolved problem. When you create something this hazardous, this unique, and this hard to get to, what do you do with it? I mean, how do you clean up something that seems to defy the very idea of disposal? People have definitely floated ideas. Hey, what if we send in robots to break it up? Well, the radiation destroys their electronics. Okay, what if we try to encase it in glass right where it sits? We just don't know enough about its internal chemistry to risk it. Well, can't we just dig it out? That would risk kicking up clouds of deadly radioactive dust. The conclusion is pretty stark. For now, and for the foreseeable future, we can't get rid of it. All we can do is hide it away. But here's a fascinating twist. Even as a permanent prisoner, the elephant's foot is still teaching us. It's not just a relic anymore. It's become an active long-term experiment. Scientists are studying how it slowly cracks and degrades under its own intense radiation, and that's giving us priceless data on how nuclear waste is going to behave over centuries. And that really is its ultimate meaning. It isn't just melted fuel. It is, as one source put it, the densest possible condensation of error, consequences, and irreversibility. It's the physical embodiment of a mistake that simply cannot be undone. Which leaves us with one final, really crucial question to ask ourselves. The elephant's foot is a legacy of the 20th century, a permanent monument to a catastrophic error. As we keep pushing forward, it forces us to wonder, what irreversible, permanent legacies, born from our own powerful technologies, are we creating right now?